Hello, our users. In this video, I want to continue our series on causal analysis using R. The topic today is instrumental variables. Instrument variables, IVs, are special variables used in statistics and econometrics to estimate causal effects when ordinary regression methods would be biased due to endogeneity. That means the explanatory variable is correlated with unobserved factors or the error term. So endogenous variables is the variable that's actually still influenced by the system. Okay, so it may be correlated with something unobserved or the error terms. Okay, and two key criteria of IVs. First, it is correlated with the problematic endogenous explanatory variable. Okay. Second, it is not correlated with the error term and only affects the outcome through the explanatory variable called the exclusion restriction. Okay, so this very critical for a variable to be qualified as an instrument variable. And instrument variables address bias when explanatory variable correlate with the error terms, causing so-called endogeneity. A valid instrument is strongly correlated with the endogenous variable relevance, but uncorrelated with the error term and affects the outcome only through the endogenous variable exclusion restriction. So we just reiterated the two key criteria. These are important. And IV estimation typically use two-stage least squares. First, predicting the endogenous variable with the instrument, and then estimating the effect on the outcome. And IVs correct biases from omitted variables, measurement errors, and the simultaneous causality. And strong instruments improve estimate precision. Weak instruments can lead to unreliable results. IVs emulate randomized experiments in observational data to infer causal effects. So they're really good for unmeasured confounders, okay? Provided that we can select a good instrument. And common instruments come from natural or policy variations unrelated directly to the outcome, except through the treatment. So how to select a good instrument is a very tricky thing, but this gives you some kind of hint, usually natural or policy variables, okay, unrelated directly to the outcome. Okay. Those can be good candidates for instruments. All right, so let's see how we can do instrumental variable analysis in R. First, let's create a synthetic data set. So random seed, sample size 200. We generate an instrument variable Z, randomly assigned, just as a binary variable, 0, 1, with probability of 1 to be 0.5. Okay. And we simulate an unobserved confounder, which is a standard normal random variable. And we simulate an endogenous explanatory variable X, depends on Z and U. Okay. And then it also add also a random error term there. Then we simulate outcome variable Y depends on X and U. Okay. So now this is the model that actually contains an unmeasured confounder U here. Okay. Then we can generate the data frame. So this data frame has Y, X, and Z. Okay, so let's take a look. This is the data set. Y is the outcome, X is the endogenous variable, and Z is the instrument. And we don't see the unmeasured confounder U because it's unobserved, okay? But since it's a simulated data, we know exactly what it is through simulation, okay? So now let's see how well the instrument variable analysis can correct this unmeasured confounder U here. So first we need an RPEG for the AER, okay? And this piece of R codes will install library AER if it's not installed, but since it's already installed, so it just loaded in. And we assume IV data is the data set with Y, X, and Z. We perform IV regression with Y as outcome, X as endogenous regressor, and Z as the instrument. And of course, remind you, we use two-stage least square 2SLS estimation. So the syntax for the IV regression is ivreg function, then when tier.x condition on Z. Okay, so that's the syntax for you to perform an instrumental variable analysis. Of course, data equal to IV underscore data. So it is pretty straightforward once you know the outcomes, the endogenous variable, and the instrument variable. Okay. And then we can just using the summary. So this is very similar to just this regular regression analysis. So the output looks also similar. You get a call, which you just tell you what you have run. You get the residuals, and then you get the coefficient. So what we're really interested in is the estimate for X. So this is the estimated effects of X on Y after accounting for endogeneity using Z as the instrument. So we know there's something unobserved that confounds the effect of X on Y, but assuming we can generate a good instrument Z to correct it, and you can see this estimated effect of X on Y after accounting for endogeneity using Z as instrument. The effect is 1.784 with a standard error of 0.226, and is highly significant, p less than 0.0001. Okay. So you can also look at R squares, which is 78%, very, very good model fit. And then there's the Wald test for the overall significance of the model. So the model looks pretty good. So we have estimated this effect of X on Y after accounting for the instrument variable Z, and it's highly significant. So this is a simple example of the instrumental variable analysis, and it's very good for accounting for unmeasured confounders. Yeah, please share this video with other people who may be interested. And if you like the video, please like our video, click on the notification, and subscribe to our learning channel. Thank you very much.